Today we will be simplifying what we call radical expressions. And the first thing we need to do is do a quick recall of your perfect squares. And your perfect squares are 1, 4, 9, 16. And I'm getting those perfect squares by taking the numbers that you count with every day, and I'm squaring those numbers. So I took 1, squared it, 2 squared, 3 squared, 4 squared, then I'll do 5 squared, I'll do 6 squared, I'll do 7 squared, okay? I'll do 8 squared, and so on, okay? All right? So we need to be familiar with our perfect squares. Now, as we look at radicals today, first of all, this is your radical symbol. And when I put a number beneath the radical symbol, that number is called the radicand. Now, as we simplify radicals today, you cannot leave a number under the radical symbol if one of its factors is a perfect square. So if one of the factors is a perfect square, you cannot leave the number under the radical symbol. For example, if I had radical 24, well, I can't leave 24 under the radical symbol because it has a perfect square factor of 4. So I'm going to rewrite radical 24 as radical 4 times 6, and I like to write the perfect square first. Then I'm going to get the square root of the perfect square. The square root of 4 is 2. So that comes outside of the radical symbol. So the simplified answer for radical 24 in radical form is 2 radical 6. If I had, let's say, radical 48. Now sometimes a number will have more than one perfect square radical, perfect square factor. So 48 has a perfect square factor of 1, a perfect square factor of 4, and a perfect square factor of 16. So I'm going to go with the greatest one, which is 16. So I would have radical 16 times 3. And the square root of 16 is 4, so I'll get 4 radical 3. But all of us don't think alike. So there are some students who may have thought of, well, if I do 48, I'll use 4 times 12. So I'm going to show you how I can take the radical 48 and use radical 4 times 12, and I'm going to get the same answer. I'm going to get the square root of 4, which is 2. But as I look at 12, I can't leave 12 under the radical symbol, but 12 has a perfect square factor of 4. So I'll write that as 4 times 3. Now I'm going to get the square root of 4, so that would be 2 times, the square root of 4 is 2, times radical 3, and 2 times 2 is 4, so I'll get 4 radical 3. But if I grab for the greatest perfect square factor first, then that would immediately take me to the answer, and I wouldn't have as much work to do. So again, we're simplifying radicals. Aaron, I just don't know what the problem is. But example 3. If I had radical 54, now I want you to think about what numbers can I multiply and get 54, but I want one of the factors to be a perfect square. So all of us know that 9 times 6 gives us 54. 9 is the perfect square. The square root of 9 gives us 3, so we get 3 radical 6 as an answer, okay? Now sometimes we will have variables under the radical symbol also. So if I had 45, x to the 4th, y to the 5th, z to the 6th, okay? Now we're going to treat these radicals as numbers that are positive, so I won't have to use any absolute value symbols. So as I rewrite this, 9 is a perfect square factor for 45, so I'll write that as 9 times 5. I can get the square root of that x to the 4th, so I'm going to leave it as x to the 4th. But y to the 5th, I need to rewrite that so that I can simplify, find some perfect squares. So I'm going to rewrite it as y to the 4th times y. And I can get the square root of z to the 6th. So as I simplify, I'm going to get the square root of the perfect squares. The square root of 9 is 3. The square root of x to the 4th is x to the 2nd. It's x to the 2nd because x to the 2nd raised to the 2nd power will give me x to the 4th. I can get the square root of y to the 4th. It would be y to the 2nd. I can get the square root of z to the 6th, which would be z to the 3rd. I don't know the square root of y. I don't know the square root of 5, so that stays under the radical symbol. So that would be 3x squared y squared z cubed times the square root of 5y. Let's do another example. Example 6. If I had the square root of 90, x to the 3rd, y to the 4th, z to the 5th. As I simplify, well, 90 has a perfect square factor up here as 9, so I'll write that as 9 times 10, x to the 3rd. I can't get the square root of it, but I can rewrite x to the 3rd as x to the 2nd times x. I'll be able to get the square root of y to the 4th. I'm going to rewrite z to the 5th as z to the 4th times square root of all of the perfect squares. 9 is a perfect square. The square root of 9 is 3. X to the 2nd, I can get the square root of it. It would be x. I can get the square root of y to the 4th, which would be y to the 2nd. And I can get the square root of z to the 4th, which is z to the 2nd. And under the radical symbol, I will write whatever I could not get the square root of. Can't get the square root of 10. Then I have x, z is the answer, right? Example 7, right? We can multiply if I have radical 2 times radical 24, okay? Now, both of these numbers are on the radical symbol, so I can multiply. And when I multiply, 2 times 24 is 48, so I get radical 48. And remember, I cannot leave a number under the radical symbol. If it has a perfect square factor, I'm going to grab for the greatest perfect square for 48. Factor for that, and that would be 16 times 3. So I end up with 4 radical 3, okay? Now there's one way that I could do that. There is another way, but I'm not trying to do too many different methods with you right now, okay? So, all right, example 8. As I do these, I'm going to go through and show you some different ways that we could do these. If I have radical 2 times radical 14, okay? All right, any radical times itself, if I had radical 3 times radical 3, then any radical times itself gives you the radicand. So radical 3 times radical 3 would be 3. If I had radical 2 times radical 2, again, any radical times itself gives me the radicand. Remember, the radicand is the number under the radical symbol. So radical 2 times radical 2 will give me 2. Because if I were to multiply 2 times 2, I get 4. Square root of 4 would be 2. So instead of multiplying these two numbers, this time I'm going to do something different. I'm going to take this and I'm going to rewrite this as radical 2 times, and I'm going to rewrite this 14 as radical 2 times radical 7. And radical 2 times radical 2 gives me 2, so I end up with 2 radical 7 as an answer. If I had decided to multiply the 2 times the 14, I would have radical 28. And remember, 28 has a perfect square factor up here of 4, and that would be radical 4 times 7. And the square root of 4 is 2, so I get 2 radical 7. So I'm just trying to show you that there are some different ways that you could take a look at these particular problems, okay? So we've simplified radicals. Now we're going to look at some division. We did a little multiplying there. Example 9. If I had 5 radical 21 divided by 15. Now 5/15 can reduce to 1/3, so I would have radical 21 over 3 as an answer, okay? And I'm safe because 21 is not a what? Not a perfect square, and the only perfect square factor it has is 1. If I were to look at, let's say I had radical 100 divided by radical 25. Well, both of these numbers are under the radical symbol, and I can divide 25 into 100, and 100 divided by 25 would be 4. So when I divide that, I get radical 4, and the square root of 4 gives me 2. If I had radical y over, let's say, radical 4. I can get the square root of 4, which is 2, so my answer would be radical y over 2. 3 plus radical 2 and 3 minus radical 2 are called conjugates. Okay. Now I'm going to multiply these. So I'm going to multiply them just like we did when we multiplied two binomials. And if you remember, when we multiplied two binomials, we used the word FOIL. So I'm going to use the word FOIL, and I'm going to use the FOIL method, and I'm going to multiply. Using FOIL, I'm going to multiply the first terms. 3 times 3 gives me 9. 3 times a negative 1 radical 2 gives me a negative 3 radical 2. Radical 2 times 3 gives me a positive 3 radical 2. And then I have radical 2 times radical 2. A radical times itself gives you the radicand. A positive times a negative gives you a negative, so I'll get minus 2. And if you notice, in the middle, the two middle terms, when you combine, gives you 0. So you have 9 minus 2, and that gives you 7. So when I multiply conjugates, I'm going to get an integer. When I multiply conjugates, I'm going to get an integer. So remember that as we go through and we're about to do some division problems. We do not leave radicals in our denominator. So if I had 3 over 2 plus radical 2, right? In order, we do not leave radicals in the denominator, so in order for me to, rationalize this denominator, I'm going to multiply the numerator and denominator by the conjugate of this denominator. The conjugate is 2 minus radical 2, so I'm going to do 3 times 2 minus radical 2. And then in my denominator, I'm going to multiply by the conjugate also. Now, as I multiply my numerator, I'm going to use my distributive property. I'm going to multiply 3 times everything inside the parentheses. 3 times 2 gives me 6. 3 times a negative 1 radical 2 gives me a negative 3 radical 2. In my denominator, all I have to do is square, but I'm going to multiply it out for you on this one, and then I'll do the shortcut on the next one. 2 times 2 gives me 4. 2 times a negative 1 radical 2 gives me a negative 2 radical 2. Radical 2 times 2 gives me a positive 2 radical 2. And radical 2 times a negative 1 radical 2, a radical times itself gives you the radicand, so that gives me minus 2. So as I simplify, in my numerator I have 6 minus 3 radical 2. A negative 2 radical 2 plus 2 radical 2, that gives me 0, so I get 4 minus 2, and that gives me 2, right? I can't do any cancellation here, so your final answer is 6 minus 3 radical 2 divided by 2. Example 13. If I had 7 over 3 minus radical 7. Again, there's a radical in my denominator. I need to get rid of it. So what I'm going to do is I'm going to rationalize my denominator by multiplying both the numerator and denominator by the conjugate for this particular denominator. The conjugate for this would be 3 plus radical 7. So I'll multiply my numerator by that conjugate, then come to my denominator and multiply it by the conjugate. In my numerator, I'll use my distributive property. I'll multiply 7 times everything inside the parentheses. 7 times 3 gives me 21. And 7 times radical 7 would give me 7 radical 7. This time in the denominator, I'm not going to go through and multiply it out completely. I'm going to use a shortcut. So all I have to do is square this first number here and square that. I get 9. Minus, and it's going to be not minus because a negative times a positive gives you a negative. And remember, a radical times itself gives you the radicand, so radical 7 times radical 7 will give you 7. And as I simplify, I get 21 plus 7 radical 7 all over 2. Example 14. If we have 5 over or divided by radical 6 plus radical 3. Again, I'm going to rationalize my denominator by multiplying both the numerator and denominator by the conjugate for this denominator. So I'll have 5 times, and the conjugate for this denominator is radical 6 minus radical 3. So I'll be multiplying both the numerator and denominator by that conjugate. Again, in my numerator, I'm going to use that distributive property, multiply 5 times everything inside parentheses. So 5 times radical 6 gives me 5 radical 6. 5 times a negative 1 radical 3 gives me a negative 5 radical 3. In my denominator, I'm going to write it a little bit different this time. I'm going to square this first number in that one, so that's radical 6 squared. A positive times a negative gives me a negative, so that would be minus. I'm going to square this, and I get radical 3, and I'm going to square it. So as I simplify, I get 5 radical 6 minus 5 radical 3. In my denominator, remember when I square a radical, I get the radicand. My radicand here is 6, so radical 6 squared will give me 6 minus. When I square radical 3, I get 3. So I get an answer of 5 radical 6 minus 5 radical 3, and that is all over 3 divided by 3. Okay. Next section, in the next section, which is section 10.3, we're going to look at operations with radical expressions. Now, I like to go back and do a recall on this when we combine like terms to let you remember recall of like terms. If you had 6x minus 3x, Remember, in order for you to do these are like terms. They're like terms because they have the same variable x with the same exponent of 1. So all I have to do is subtract those numerical coefficients. So 6x minus 3x would give me a 3x, okay? If I had 7x plus 6y, I could not add those because those are called unlike terms. So we're going to treat our radicals the same way that we treat our variables. So we're about to simplify. So if I had radical 2 plus 3 radical 2, well, I'm going to treat these just like I do my variables. These radicals are alike, and because they're alike, I can add. So I'll add the numerical coefficients. Remember, there is a 1 understood to be here, just like when you just had x. The numerical coefficient for x was 1. So there is a 1 understood to be here, so I'll add 1 plus 3. So my answer would be for radical 2. If I had a negative 7 radical 3 plus 5 radical 3. Well, these radicals are alike, so those are like radicals, so I can combine these. This 7 is negative, that 2 is positive. A negative 7 plus 5 gives me a negative 2. So my answer would be a negative 2 radical 3. If I had a negative 9 radical 7 minus 6 radical 7, again, they have the same radical. So I will combine the negative 9 and the negative 6, and the negative 9 and the negative 6 when I combine gives me a negative 15. So my answer is a negative 15 radical 7. So as long as the radicals are alike, then I can add or subtract. So let's see what happens when they are not alike. Example 4. If I had 2 radical 18 plus 2 radical 32 plus radical 72, okay? Right? Well, all of those radicals are unlike, okay? But go back and recall that I cannot leave a number under the radical symbol if one of its factors is a perfect square, okay? So 18 has a perfect square factor. So I'm going to rewrite that as 9 times 2. 32 has a perfect square factor. Now it has more than one perfect square factor, but the greatest perfect square factor is 16. So I'll rewrite that as 16 times 2. And 72 also has several perfect square factors, but I'm going to grab for the greatest one, and the greatest one is 36, so that's 36 times 2. Now we're going to simplify. I'm going to get the square root of the perfect square. The square root of 9 is 3, so I'll have 2 times 3 times radical 2. The square root of 16 is 4, so I'll have 2 times 4 times radical 2 plus the square root of 36 is 6, so I'll have 6 radical 2. As I simplify, 2 times 3 gives me 6, so I get 6 radical 2. 2 times 4 gives me 8, so I get 8 radical 2 plus 6 radical 2. And 6 plus 8 gives us 14, so we get 14 radical 2 plus 6 radical 2, and 14 plus 6 gives us 20, so our answer is 20 radical 2. So even if the radicals are not alike, we can simplify. Again, if a number under the radical symbol has a perfect square factor other than 1, then we cannot leave that number under the radical symbol. If I had radical 8 plus radical 12 plus radical 18. Let's simplify. We cannot leave 8 under the radical symbol because it has a perfect square factor of 4. So I'm going to rewrite that as radical 4 times 2 I cannot leave 12 under the radical symbol. It has a perfect square factor of 4. So I write that as radical 4 times 3. And I cannot leave 18 under the radical symbol because it has a perfect square factor of 9. Now let's simplify. Again, I just make it a habit of writing my perfect squares first. The square root of 4 is 2, so I'll have 2 radical 2. The square root of 4 is 2, so that gives me 2 radical 3. The square root of 9 is 3, so that gives me 3 radical 2. And if you notice, these radicals are like terms, so I can combine 3 radical 2 plus 3 radical 2 gives me 5 radical 2. So I get 5 radical 2 plus 2 radical 3. Again, you cannot leave a number under the radical symbol if one of its factors is a perfect square. So I've shown you how to simplify. I've shown you how to add and subtract. Now let's look at some multiplication. This should be the examples. Let's look at multiplication. If I had radical 5 times the expression radical 2 plus 4 radical 2. Right? Again, I'm going to use my distributive property. I'm going to take this radical 5 and multiply it times everything inside the parentheses. So when I multiply radical 5 times radical 2, because both of these numbers are under the radical symbol, I can multiply them. 5 times 2 is 10, so I get radical 10. Plus, when I multiply here, I can multiply the radical 5 times the radical 2 and get 10, so I get 4 radical 10. The numerical coefficient here is a 1, and 1 plus 4 gives me 5, so that gives me 5 radical 10 as an answer. Example 7. If I had 3 radical 11 plus 3 radical 15 and the binomial 3 radical 3 minus 2 radical 2. Okay? And again, we have multiplied binomials before and we use FOIL, so I'm about to use FOIL on this. I'm going to multiply 3 radical 11 times 3 radical 3. So I'll multiply 3 times 3 and get 9. Multiply radical 11 times radical 3 and get radical 33. Now take this 3 radical 11 and multiply it times the negative 2 radical 2. 3 times a negative 2 is a negative 6. And radical 11 times radical 2 is radical 22. Multiply 3 radical 15 times 3 radical 3. 3 times 3 gives me 9. And radical 15 times radical 3 gives me radical 45. Multiply 3 times a negative 2. I get a negative 6. And radical 15 times radical 2 gives me radical 30. Now as I look at that, I need to look at it and see, is there anything there that needs to be simplified? Well, 45 has a perfect square factor other than 1. It has a perfect square factor of 9. So that means I need to simplify this. So I have 9 radical 33 minus 6 radical 22 plus 9 times the square root of, I'm going to rewrite this as radical 9 times 5. So when I finish, my answer is 9 radical 33 minus 6 radical 22. The square root of 9 is 3, so 3 times 9 is 27. So that gives me 27 radical 5 minus 6 radical 30.